Hello, I'm Lord Tony, and today we're going to be talking about a problem from AngstromCTF. Now, I'm pretty sure angstrom isn't actually a real word. I think the organizers just liked the word angst. Okay, and with that joke out of the way, let's jump right in. So, here's a challenge that I did not solve while the tournament or the CTF was going on, and it is called Secure Vault. Now, I read like 3 different write-ups that all had 3 different ways of solving this problem, and the one at the end was like completely bonkers. So let's just get right into this, and I'll show you some of these hack tricks. So first of all, they give us the link and the source code. So here's the source code, and here's the link to the actual secure vault. So kind of describing what goes on here, there's only a few features. Actually, I think looking at the code makes a lot of sense here. So we've got this use piece, which this is a website using the Express framework. So here's the server-side code. It looks like what we're doing for every single page is we're going to basically be creating a JWT using a JWT key, and that key is math.random. So for those of you who know about JWT, you can actually forge JWT if you have the key that they use to sign it with. But this key right here is like 15 digits, 16 digits, something that is just not reasonable. Like, even though we know what format it's going to be, this is not reasonable, even with like a really good GPU, to brute force all of these math.random numbers. So, basically you can't crack the JWT, or so I thought. We'll get into that later, but you can't brute force crack it. So we got to pay like a command for registering a username. We got a command for logging in. We got a command for deleting a user, and we've got a command for updating our vault with a post, and we got a command for getting information back from the vault with a get, and that's basically it. So you create a username, and this one's probably taken, but we'll give it a shot. Okay, well, ABC123 can't log in like that. And if I try to register the name, it already exists. But if I just pick up like a completely random thing and I register the name, it says, oh, put something here, and you can change this, and this is the button that does that update vault post. But when you originally load this page, if you're logged in, it'll pull your vault information and throw it right there. So we can see that the way that we're going to get the flag, so here's the flag up here, they're getting it from the environment variables. They are testing if our user is not restricted. So if our user is restricted, we'll just get what our information was that we had saved in the vault. If our user is unrestricted, we will get the flag. So we need to find out how to get the user unrestricted. But you could probably do this naively. So the way to solve this, if you're just kind of messing around, is to find out, where are the cookies here? Yeah. So we got our JWT from logging in that was created, this big pile of crap here, and we can go to jwt.io, and this is a nice pretty way to see what the contents are. So we've got this UID right here, and that was also generated with math.random. That's basically our user ID for this account. What we can do is, if we copy this and then delete our account, and then just put that, try to log in with that token that was just deleted out, what we get without understanding it all is the flag. And so you might just leave it at that, because a flag is a flag. because this is the one way I think they intended to solve the problem. Because here, it's even in the flag. Is this what UAF is? UAF is use after free. We deleted the account and, quote unquote, freed the memory, and we were able to use the thing after we freed it. So that's not exactly what's going on here. What's going on is more of a type juggling problem. So that comes to our second write-up and our second way to solve this. So let's just delete this out again. And I'll pull up code here. So this is a simple piece of code. We got our session. And I'm going to try to log in with the username Lord Tony, password 123. Now that username I know doesn't exist. And then we're going to look at what the URL that we get redirected to is, and we're going to see if that session was given any token cookie. So let's run this with Python 3 and juggle is the name of this. What is going on here? Data in line of post, unexpected argument. Oh yeah, lowercase d data, I think. There we go. Okay, so when we fail to log in, it just gives us this URL, invalid password, username. But before I show you what the trick is, let's dive back into the source code here. So what happens is every request checks that token cookie, and oh wait, no, I'm getting a little mixed up here. So what happens is when we try to get a user, we basically look in their we look in that JWT they've given us, we verify it to make sure it's signed with the correct password, and then we try to get it out of the list of users with a UID. Now, if that user doesn't happen to exist, we give them instead an empty object. So when we hit the vault page, or is it? No. When we hit the login page, yeah, here it is. When we hit the login page, what we're doing is we're doing a user lookup for whatever the username is that's sent as part of this post, and then we're getting that user. So what we can do to hack this a little bit is we can just send no data at all. This might seem a little crazy, but we'll walk through it. So we send no data at all, and what's this? It says we've logged in correctly, and it even gives us a JWT for it. So let's copy that JWT and take a quick look. Like, what's going on? Let's see what it looks like. There's no UID in here. The UID is going to be undefined. So how did that happen? Well, what happened was we didn't provide a username, so when it did this user lookup, it did this .usernames and then tried to get the username out. It wasn't in there, so we got back undefined. So with it being undefined, now we pass undefined into the get, and that passes back an empty object as a user. So that empty object has no properties in it. So it does evaluate as truthy, so there is a user, it's just an empty object, and then that empty object doesn't have a password field, so that password from the empty object is undefined, and then in our request body, we're also not sending a password, so that's undefined, and undefined is equal to undefined. So when so it makes us a cookie. It makes us a cookie with no user ID, basically undefined, and then it signs it. So what we have right here is a valid cookie with no user ID. And if we create this token, I think token is the name of the cookie they're looking for, and we pass that in there and reload the page, we get this. We get the flag. The reason we're getting the flag, which I didn't understand when I first did this, is because right here we've got no UID, so that's undefined, and we end up, again, getting that empty object back. And when we try to grab the vault information, what we find is user is now an empty object. And when you try to get .restricted, that is undefined, and it evaluates as false. So, because we're not restricted, because restricted doesn't exist in that object, we're not getting the user's vault, we're getting the flag. And so that is really what's going on with this. But there's a third way to solve this that's even more bonkers, that I had to jump through some serious hoops in order to discover. And it basically comes from this guy, Satoki. Now, it was really difficult to decipher this because Satoki is Japanese. And even though I'm a huge weeb, I can't read kanji. And I can't make sense of technical Japanese. So I had to kind of thumb through this and see if I could figure out what he was doing from the code he posted. And he posted something really interesting here. He posted this link. And yeah, this link goes to this GitHub page. And after reading through this document, I realized what this Python script does is if you provide it five math.randoms in a row from JavaScript, it can reverse engineer it and figure out all of the math.randoms that came before because it uses a predictable algorithm. It's not cryptographically secure. So what we know about our code is every time we create a new user, every time we insert a new user, we call math.random, and this is a JavaScript server-side library, so they're using the algorithm that the JavaScript in your browser would be using. So we can create a user, we can create 5 users, look at what their UIDs are from the JWT, and then use those 5 and backtrack and use that in order to find out what that JWT is. In order to find out what the key is that they're using to encode the JWT, because they're using math.random for the key, and we have an oracle here. So what I've done, and what Satoshi did here, is he he created 6 new accounts, then he looked at what the he looked at what the JWTs from those accounts were, and he pulled out these chronological numbers, and then he fed it back into the application, and sort of he changed, instead of giving 15 previous entries, he generates 50,000 of them, and he sticks those in a dictionary and feeds it into a JWT cracker program. So that's what I'm going to do. I'm going to crack this JWT. And so what I've done is I've taken that script right from the GitHub page, that reverse engineer script, and I'm sticking my own stuff in the main method. So in main, I have written a script that basically does the same thing. I'm going to create a bunch of users named Beef Stew, and then I'm going to decode what the UID was in those JWTs, and I'm going to feed that into dubs. Now, that is what they use to reverse engineer. So I'm going to go ahead and take the last 100,000 times math.random was called and make a word list out of it. And hopefully one of those calls is going to be the password to the JWT. So we can take this JWT here because all of them are going to be using the same server key. So I'm just gonna echo that. Whoops. I'm just going to echo that into a file called crackme. And then in is, I believe, like no line break or something. So that's why the in is there. And then what I'm going to do is I'm going to run that Python juggle program, and I'm going to feed that into a file called wordlist. And that should give me 100,000. Actually, you know what? I can show you how this works just to see what the printout is, because I'm sure you're curious about it if you've watched this far into the program. I need to turn this into junk too. So Let's run that just so you can see what the output looks like. Oh no, that was juggle. Oops, I made juggle into the word list. I didn't even run my program. Okay, so clearly I've done this before. Yeah. So I'm gonna make my word list, beef stew. And you need new names, otherwise it's not gonna work. So that's why I keep changing that there. So I'm gonna create my word list. Give me 100,000 files, please, or 100,000 of those, and I'll show you what it looks like when we only print out a few of them rather than 100,000. Oh no, that's only 10. Ah! This is just a comedy of errors today. Give me 100,000, please. Okay, that should be 100,000. And then now back to just printing out 10 so you can see the format of the word list. Okay, so you can see it shows us what we got out of our JWT tokens that we generated. JWT token, yeah, like ATM machine, automatic ATM machine. Okay, and so these are some of the entries that math.random would have given us before these. So it uses the trick to reverse engineer it. So now we have a word list and we have a JWT to crack. So let's pop it into John the Ripper. And this is how we're going to do it. So we say John, and then we give it the JWT that we want to find the password on. And we say format is HMAC-SHA-256, all caps. Now that's really frustrating for me because I would like to write the word JWT in there. I don't know why, like, I guess that's what the JWT encoding is, but I don't know. I feel like they should just accept the word JWT. Why do they got to be tryhards about it? But anyway, let's run John the Ripper, and oh wow, we actually cracked it in like a split second. This would have been nearly impossible to brute force, but because we could reverse engineer the math.random they were using, now we were able to create a good word list. And well, we've cracked it, and we can verify this has been cracked because this will. Right now, this tells us we got an invalid signature. If we put that password right in there, it can verify that this was signed correctly. Like the JWT we provided was signed with that, and it also allows us to. It also allows us to fabricate pieces of information we want in here. So we can set our UID to, I don't know, fat face. And, oh yeah, and then we need a comma. Okay, there we go. So now we've got a fabricated JWT. And we can, in fact, pass this in there. And we pass the JWT signature check, and we do get this with our fake, fat face UID, because fat face definitely does not exist as a valid UID in our list to check, based on that other thing I showed you where it all becomes undefined. So one other thing I'd like to mention about Satoshi's write-up, or Satoshi? Was it Satoshi? Satoko? Satoki. There we go. I was so close. So Satoki, I think he thought he found some sort of admin UID here because he's using the math.random to sign it, and he's also using the same math.random as a UID. I think he thought that was like the admin's UID, but if we look at the source code one more time, there is no admin UID. Every account that's created is restricted. So I think he accidentally got the answer, even though he did like the bonkers thing of figuring out how to reverse engineer like math. Well, I mean, he found somebody else's code to do it, but even still, that's hard research to do. he found math.random in a way to like backtrack it, and he was actually able to crack like what I would consider an uncrackable JWT password. So really impressive stuff. So yeah, I guess I will talk to you guys later. I got stuff to do.